America wanted the clean energy transition to create independence. But the uncomfortable truth is this. A huge part of that transition now runs through a supply chain America does not fully control. Not oil wells, not pipelines, not Middle Eastern shipping lanes, but solar wafers, battery materials, graphite processing, rare earth magnets, inverters, refining capacity, and the factories that turn raw materials into usable energy technology. For decades, energy security meant access to oil and gas. Today, it increasingly means access to the industrial system behind solar panels, batteries, electric vehicles, grid equipment, and critical minerals. And over the last 15 years, one country built more of that system than anyone else: China. China did not just become the world's biggest clean tech manufacturer. It built the upstream and midstream layers that everyone else now depends on. The polysilicon before the solar panel, the wafer before the cell, the processed graphite before the battery anode, the refined minerals before the electric vehicle, the manufacturing clusters before the final product ever reaches an American project site. So when the United States talks about energy independence, domestic manufacturing, grid reliability, or competing with China, there is one uncomfortable question underneath all of it. Can America build the clean energy future without relying on the country that already built the clean tech supply chain? That is why this story is not just about cheap solar panels. It is about industrial power. For the United States, this matters because clean energy is no longer just climate policy. It is becoming industrial policy, national security policy, grid policy, trade policy, and economic strategy at the same time. America wants more solar farms, more battery storage, more electric vehicles, more domestic manufacturing, and a more resilient grid. But every one of those ambitions depends on physical supply chains, not slogans, not tax credits alone. Actual factories, actual processed materials, actual components that can be delivered on time, at scale, and at prices developers can afford. A solar panel installed in Arizona may look like a local energy asset. A battery project in Texas may look like American grid infrastructure. An electric vehicle plant in Georgia may look like a domestic manufacturing win. But the deeper supply chain often reaches far beyond America. The polysilicon may be processed overseas. The wafers may come from Asia. The cells may be manufactured abroad. The battery anode materials may depend on Chinese graphite processing. And the cathode chemistry may rely on minerals mined in one country, refined in another, and turned into usable battery materials somewhere else. This is the difference between assembling clean technology and controlling the supply chain. America can build final assembly plants, subsidize domestic factories, pass tax credits, impose tariffs, and announce industrial strategies. But if the upstream and midstream layers remain concentrated outside the United States, the system is still exposed. The issue is not that America cannot install renewable energy. It can. The deeper issue is whether America can build, scale, and maintain that system without depending too heavily on a rival power. That dependence affects energy costs because supply chain disruptions can raise project prices. It affects grid reliability because delays in batteries, transformers, inverters, and components can slow deployment. It affects manufacturing jobs because clean energy factories are now part of the next industrial employment race. And it affects national security because batteries, critical minerals, rare earth magnets, power electronics, and grid equipment overlap with transportation, defense, data centers, and industrial infrastructure. This is why the clean energy race is not just about deploying technology. It is about owning the industrial base behind the technology. And China understood that earlier than most of its competitors. China's clean tech dominance did not happen by accident. It was built through scale, policy, industrial clustering, export strategy, and relentless manufacturing learning. The first layer was domestic demand. China built enormous internal markets for solar power, electric vehicles, wind energy, batteries, transmission, and grid infrastructure. Factories do not become globally competitive in isolation. They need customers, volume, repeat orders, and engineers solving production problems every day. China created that environment by building a huge domestic clean energy market. When solar deployment grew, solar manufacturers gained scale. When electric vehicle adoption accelerated, battery companies gained scale. When grid expansion required equipment and power electronics, domestic suppliers developed around that demand. This created a reinforcing loop. More deployment supported more factories. More factories lowered costs. Lower costs supported more deployment. And that experience made the next generation of factories more efficient. The second layer was manufacturing clusters. China did not build clean tech supply chains as isolated factories scattered randomly across the country. It built dense industrial ecosystems. In a clean tech cluster, battery cells, cathode materials, separators, equipment, chemicals, logistics, testing, and automation can all sit inside one dense ecosystem. This matters because modern manufacturing is not just about one factory being cheap. It is about the speed and density of the entire network. If suppliers, engineers, logistics, and equipment makers are nearby, problems get solved faster and production lines improve faster. That is difficult to replicate. A country can announce a battery factory, but building the surrounding supplier base is much harder. A country can subsidize solar module assembly, but building the upstream system for polysilicon, ingots, wafers, cells, glass, frames, junction boxes, and specialized equipment takes time. This is where China's advantage becomes deeper than price. It is not only that Chinese products are cheaper, it is that China has accumulated the industrial muscle to make them cheaper at scale. The third layer is midstream control. This may be the most important part of the story. When people talk about critical minerals, they often focus on mining. They talk about lithium, cobalt, nickel, or rare earth elements. But in many clean energy supply chains, the strategic bottleneck is not only the mine, it is the processing. A mineral in the ground is not yet a battery input. A rare earth deposit is not yet a permanent magnet. Graphite is not automatically battery-grade anode material. Lithium is not automatically usable in a cell. The material must be refined, separated, purified, processed, and manufactured into something that meets industrial specifications. China has spent years building capacity in those middle layers. That is why its dominance is so powerful. It does not need to own every mine in the world to shape the supply chain. If it controls enough refining, processing, component production, and manufacturing capacity, it can still become the central hub. This is what makes the clean tech supply chain different from a simple commodity market. The question is not only who has the raw material, the question is who can turn that material into an industrial product at scale. That capability is what China built. In solar, the pattern is especially clear. The panel on a rooftop or utility-scale project is only the final stage of a long process: polysilicon, ingots, wafers, cells, and modules. China built deep capacity across those stages. That means even when another country assembles panels domestically, it may still depend on upstream components shaped by Chinese manufacturing capacity. The same pattern appears in batteries. A finished battery pack depends on cells, cathodes, anodes, separators, electrolytes, casings, and precision manufacturing. So when America says it wants a domestic battery industry, the challenge is not just building battery plants. It is building a complete materials system that can feed those plants. The fourth layer is cost compression. Once China built enormous manufacturing capacity, prices fell. That helped the world deploy clean energy faster. Solar became cheaper. Battery storage became more viable. Electric vehicles became more competitive. Grid-scale projects became easier to finance. Cheap Chinese manufacturing made the clean energy transition more affordable. But it also created a strategic trap. If Chinese supply chains become so efficient that other countries cannot compete without heavy subsidies, then global deployment becomes tied to China's industrial base. The world gets cheaper clean energy, but it also gets deeper dependence. This is the central conflict. The same supply chain that made clean energy affordable also made it strategically uncomfortable. For the United States, tariffs and industrial policy are attempts to change this equation. Washington wants to protect domestic manufacturers, reduce dependence on Chinese components, support allied supply chains, and prevent U.S. subsidies from strengthening a rival industrial system. But there is no easy solution. If tariffs are too low, domestic factories may struggle. If tariffs are too high, projects may become more expensive. If rules are too strict, developers may face delays. If rules are too loose, dependence remains. This is a trade-off between speed, cost, security, and industrial resilience. Project developers want cheap equipment. Domestic manufacturers want protection. Policymakers want strategic independence. Utilities want reliable delivery. These goals do not always align. A cheap solar panel can be good for deployment and bad for domestic manufacturing. A tariff can be good for a factory and bad for a project budget. A domestic content rule can strengthen long-term resilience while slowing short-term construction, and a supply chain that looks efficient in peacetime can become a vulnerability during geopolitical stress. This is where the story becomes larger than energy. Clean technology is now part of geopolitical competition. China's position gives it several forms of leverage. It has price leverage, because massive capacity can push prices down and pressure competitors. It has volume leverage, because the supplier that can deliver huge quantities on time often becomes the default choice. It has learning leverage, because high-volume production creates process knowledge. And it has diplomatic leverage, because emerging markets want affordable energy infrastructure now, not years from now. Chinese solar panels, batteries, and grid equipment offer a fast path to deployment. That makes China a central partner in the energy transition of emerging markets. The United States understands this risk. That is why it is trying to build alternative supply chains with allies. It wants more production in North America, more processing in friendly countries, more battery capacity outside China, more domestic solar manufacturing, and more control over critical inputs. But building a supply chain is much harder than announcing one. Factories require capital. Permits take time. Skilled labor must be trained. Processing facilities face environmental and regulatory hurdles. Customers need long-term contracts. Suppliers need predictable demand, and investors need confidence that policies will not change after the next election. China's advantage is that it spent years building the full ecosystem, while many Western countries outsourced manufacturing and focused on final markets. Now the United States is trying to rebuild industrial capacity in a world where China already has scale. That does not mean America cannot catch up in key areas. It can. The United States has capital markets, advanced research, software, grid expertise, engineering talent, major energy companies, and strong domestic demand. But catching up does not mean copying China in every category. The more realistic strategy is selective resilience. America does not need to produce every single component domestically, but it does need to identify the bottlenecks that matter most: battery materials, grid equipment, power electronics, critical mineral processing, advanced manufacturing equipment, recycling, high-voltage transmission components, and technologies where future industrial leadership is still open. The goal should not be total isolation. That is not realistic. The clean energy system is global. Raw materials come from many countries. Components cross borders. Allies will matter. Trade will continue. And in some areas, Chinese products will remain difficult to replace quickly. Trying to remove China from the clean tech system overnight would likely raise costs, delay projects, and slow deployment. That would hurt the very energy transition America is trying to accelerate. But doing nothing is also risky. A country that depends too heavily on one rival power for the materials and components behind its energy infrastructure is not truly energy independent. It may have solar panels on its land and batteries connected to its grid. But if the supply chain behind those assets can be disrupted, restricted, or politically pressured, then the system still carries strategic exposure. The real solution sits between two extremes: not blind dependence, not full decoupling, but managed diversification. That means building domestic capacity where it is strategically necessary, working with allies where it is economically efficient, creating transparent supply chains, developing recycling and circular materials systems, supporting processing capacity outside China, using industrial policy carefully, not just as a subsidy machine, but as a way to build durable ecosystems, and accepting that resilience costs money. A supply chain built only for the lowest price will usually concentrate wherever production is cheapest. A supply chain built for resilience must include redundancy, geographic diversity, trusted suppliers, and strategic reserves. That costs more in the short term, but it may prevent much larger costs during a crisis. For years, the clean energy conversation focused on deployment. How many gigawatts of solar? How many electric vehicles? How much battery storage? Those questions still matter, but they are no longer enough. The new question is deeper. Who controls the industrial system that makes deployment possible? Because the country that controls that system does not just sell products. It shapes prices. It shapes timelines. It shapes competition. It shapes the options available to other countries. And it gains leverage over the future of energy itself. China understood this early. It treated clean technology not only as an environmental opportunity, but as an industrial strategy. It built capacity before demand was fully mature. It accepted overcapacity as part of the race for scale. It connected domestic deployment with export power. It built clusters, processing capacity, manufacturing expertise, and global market share. Now the rest of the world is trying to respond. America is trying to rebuild manufacturing. Europe is trying to reduce exposure. India is trying to expand its own industrial base. Emerging markets are trying to balance affordability with dependence. But everyone is operating inside a clean tech system where China has already become the central manufacturing force. China did not simply build clean technology. China built the clean tech supply chain America cannot escape. Not because America has no options, but because every realistic option now begins with the same fact. China is already embedded in the industrial foundation of the energy transition. The next phase will not be about whether the world uses clean energy. That direction is already clear. The next phase will be about who builds it, who profits from it, who controls the bottlenecks, and who carries the risk. Solar panels and batteries may look like energy infrastructure, but behind them is a much larger machine. A machine made of factories, materials, suppliers, ports, processing plants, engineering knowledge, and political choices. China spent years building that machine. America is now trying to build its own version while still depending on the original. And that may be one of the defining industrial conflicts of the clean energy era.